So today we will be working on assignment review number 3. We are on page 7. Today we're doing transformations and functions. This part up here on my page where it says focus and directrix, we took that out. So for question 1, it says the quadratic function f of x has a turning point at 5, -8. So this part right here is important. That's a point. Now they tell us if g of x takes f of x and adds the quantity x plus 7 and then subtracts 3, what point does g of x have a turning point? So basically what this has done is it has moved all points left 7 spaces, because remember, if it's in parentheses, you're doing the opposite. And then this -3 moves all of the points down 3 spaces. So if we're changing a point, we have this point -5 or 5, -8. So if we move left 7, what we're going to do is subtract 7 from the 5. So we end up with the x value of -2. And then if we move down 3 spaces, we're going to do a -3 to the y value. So we have the point -2, -11. We're going to do the same type of thing with question 2. We have the point -3, 7. Okay, that's on the graph of f of x. Then what must lie on the graph of y equals 5 times f of x minus 20? So what we have to do, this is actually 2 steps. We're going to multiply the y by 5, okay? And then we subtract 20 from the y. Just like you do order of operations, you're going to do the same thing here. We're going to multiply the y by 5, so we end up with -3, 35, and then we subtract 20 from it. -3, 15. So the point -3, 15 also has to be on there. Okay, now we're going to delve into a little bit of even and odd functions. When you see a graph, and on mine you can see it's kind of hard to tell what's what because some of the lines are lighter, some are darker, but we have this parabola, quadratic equation, we have an absolute value equation. This looks to be some type of cubic and some type of backwards sine or cosine function. I'm also just going to highlight my axes because it's really hard to see on here. And because they want an even function, I'm just going to look for symmetry. An even function means the graph is symmetric about the y-axis. So if you look, number 1 is the only graph that's symmetric over the y-axis. Okay. Number 2, not. Number 3, it looks like it has some symmetry, but if you look, they're not symmetric over the y-axis. And this one looks like there's a pattern, but if you take this point and move it over the y-axis, it's not there. So for question 4, it says, which of the following statements is true about this function? Let me see if I zoom in. I don't have high hopes. Okay, it's a little bit better. So it talks about degree and if the function is even or odd. So we'll review degree. That has to do with the biggest exponent in your function. So if something is an odd degree, the arrows are going to point in opposite directions. Like an x to the 3rd or an x to the 5th. If something is an even degree, the arrows are going to point in the same direction. They'll either both point up or they'll both point down. Some variation of those shapes. That's for degree. Now to say if the entire function is even or odd, there's 2 different ways to do this. I'm actually going to look at points. We could go over symmetry, but if you have points, let's start with odd. If you have an x and a y point, in order to be an odd function, those same numbers have to be on the graph, but both the x and the y are negated. The signs are opposite. To be an even, you still have a point, but in order to be an even function, only the x is negated, the y stays the same. So let's go with that. This is an odd degree. The arrow, one arrow points up and one points down. So we know the degree is odd. Let's see if I can cross something out to start with. The degree of the function, I don't want to zoom out yet. The degree of the function is odd. So I can cross this one out and I can cross that one out. Okay? So I'm going to cross out 2 and 3. 3 and 4. Now we have to see if the entire function is odd. So I'm going to take a look at this point right here. So when I did this on my actual paper, I saw that the point was -4, 5. So to be an odd function, we also have to have the point. Remember, you negate the x and y for -5. So when I plot 4, -5, it's really hard to see. I'm going to say it's like right about here, give or take. It's not there. The graph is down here, okay? That means it is not an odd function. It has an odd degree, but it's not an odd function. So our answer would be number 2. We'll go to the next page and do number 5. The graph of the function f of x is shown below. The function g of x is defined by this formula. G of x equals -2 times f of x. Produce the graph of g on the grid. You could just use the graph to do these problems, although mine is really hard to see. If you're struggling with finding places, what you could do is just write the points down on this graph, which I'm going to do real quick. Now, I'm going to transform my points. This says -2 times our y value, whatever that is. So my new function, we'll call it g of x. X stays the same. Multiply the y value by -2, so that's 74. X stays the same, y becomes -6. X stays the same, y becomes -6. X stays the same, y becomes +6. So now all I have to do is plot those. So again, it's really hard to see on here. I'm going to say it's about here. This graph is not exact because I can't actually see the points, but hopefully you get the idea. And that's up there. Now it says, for part B, solve the equation, f of x equals g of x for all values of x, just the x. So what you're doing is looking to see where they intersect. So they intersect at the points -5, 0 and 3, 0. So we would say our answer is x equals -5 and 3. You can write it like this, or in your brackets, you can write -5, 3. Same thing. Okay, the last one on even or odd is this problem. The function f of x equals x to the 4 minus 8 over 4x is an even function or an odd function. Provide evidence to support your answer using a table or a graph. So you could use your graphing calculator. It's quicker for me to just pull up Desmos. I'm going to type this in here. I'm going to do parentheses. I do the parentheses so that way the computer knows that whole thing is in the numerator. Now I'm going to look on my table. All right. You could check more than these. Let's see. It's going to bother me. It's a little out of place. So what I'm going to do is copy this table down on my paper. And I'm only going to go from -2 to 2. So -2, -1. Now we know 0 is an error because it makes the denominator 0. So you could include that or not include that. It doesn't matter. So we have -2, -1, 2, 1. And then what have we got going here? 1.75 and -1.75. If you put this in your graphing calculator, they would give you 7/4 and -7/4. Here's my evidence. I wrote a table. Now I am going to say this is an odd function. A couple different ways you can explain this is you can say the x and y are both negated. Negated means opposite signs. And here's an example. We have the point -2, -1, and the point 2, 1. Now, on my table on Desmos, I actually went and checked out 3 and -3 because sometimes one could work, but they really all have to work. We're going to do another video with our next section, which is working with inverses. So make sure you tune back in to watch that one.